All right, welcome back to another week of OS Dev Gardening. I think this is week 12, and if you're new here, this is where I embarrass myself on the internet as I try to work on an OS. And what I just realized actually is kind of alarming. I think I've been using a really old version of XV6 or something like that, which that's just the one I got from GitHub, which I thought was like as up to date as it could be. But I've been going through like all these actual kind of coursework for the real courses that use this class, and I saw a bunch of weird stuff, like how this MIT stuff, even from 10 years ago or 12 years ago, is talking about something totally different, which is like this JAWS thing actually, which actually has like directories for the source files, which I spent way too long trying to add in the first like 5 episodes of this stream. So I'm a little bit calling into question what I'm even doing here. I'm also considering switching over to the OS 161 project, which is from GitHub, from Harvard, which seems kind of better than XV6, although it doesn't use x86, it uses MIPS, which I don't love because I kind of wanted to do x86, but yeah, something like this whole thing they're saying seems very nice, so I might switch to that later. But for the meantime, I'm not going to make any big changes. I'm just going to keep working. I'm just going to keep doing what I was doing, which are these cleanups to defs.h. Yeah, I might be wasting like all my time trying like doing this cleanup if I eventually switch to a different code base. I hope I didn't. I mean, maybe. It doesn't matter either way because I'm like having fun and like doing a bit of learning either way. But yeah, eventually it would be nice to actually get into a bit more real OS dev. But for the moment, let's keep working on this. And so, just a quick test as we start off. As usual, I'm gonna get on that side, make clean, make Kimu. Yeah, we're in a building state, which is always good. And we'll just do a quick review of the Git. So we were just doing a bunch of these cleanups and moving things out into header files. And I'm just going to keep doing that, even though this whole thing might be like totally moot. I'm just going to keep doing this because it was like, kind of fun and satisfying. And I did learn a bit of stuff about the OS through doing it. So we finished a lot of the easy ones. And now we're on to the harder ones. What's kind of interesting, this is interesting, string.c. I wonder if that file is shared between the kernel and user space, actually. So let's just, like, who's calling safe stern copy, for example? I mean, my belief is that these are only from the kernel, but I might be totally wrong. Otherwise, maybe there's two implementations of all this stuff. So these are system calls, but yeah, like this is kind of what I'm talking about. I think there might be two separate implementations of all this stuff, which is kind of yucky. We have the ulib, and we have string.c. Yeah, I think, is there Sterling? Yep, it's duplicated. It's actually copy and pasted. So that is a point, yeah, of cleanup later. Interestingly, the return type is different. Is that even correct? I guess it doesn't really matter. Whatever, okay. Anyway, I'm not really focusing on user space for the moment. I am focusing on the kernel. And let's continue. So yeah, let's port string.c. Or should we? I'm just thinking if we later want to unify things between the kernel and user space, maybe we don't want to do that. Nah, whatever. Let's just do it. Okay. So what's a good thing? So I think I was just like copying. I'm going to duplicate this once more. String dot h and yeah, this can go over here. So the idea was now to go through all of these. Yeah, take all of these, put them here. We definitely need types.h because of all these uints everywhere. And now let's look for all the mem comps. And yeah, string.h. Yeah, that's it. Interesting. Mem move. This is a bit, yeah, juicier. Save that into register. Fs.c. grep.c. log.c. Actually, wait, grep, I know that's wrong. That's user space. We do not want to be touching user space. Ls, it's main. This is the kernel, yep. Is it even right? String, whatever. I'm just conceptually thinking whether it's even right for the mem comps and stuff to be in string.h, but I guess, yeah, sure, I guess it is. Okay. And lastly, vm.c. Oops. Memset. Console fsk alloc. Okay, alloc makefs. Proc already has it. No, it doesn't. This file is going to need this. Yeah, I've already got that. Safe, stir copy, exec.c. That's in the kernel, right? Yep. Proc, already got that. Easy. Stir len. Exec. It's actually less usages than I would have thought. Okay. Fs, already got that. Stern copy. Fs. Nice. Save this. And do we build? Oh. No, we don't. What happened here? Console dot, what? Did I forgot to save? Yeah, I think I did. Okay. We're still running. good. Get my fork out too. Oops, remind me later. Okay. So typical thing was, okay, first, take this, move that into here, right? Code movement. Oh yeah, forgot one thing. String.c. Now starts with that. Okay. Cool. Now we just have all the clients. Good. Create string.h. Nice and relaxing, very easy stuff. Okay. Syscall.c. Syscall.h. Oh, what's in syscall.h? Oh, this is called numbers. Who uses these? It seems totally private. Although, userspace doesn't userspace need them? Set against syscalls. It's worth a check. How does userspace trigger syscalls? Or no, this is not what I wanted. What file is that? There's so many files here. It's so hard to understand. It is ulib, I think. Yeah, I don't know. What's it? How do we find? It's user.h, right? User.h declares all this stuff. And at some point, there's going to need to be like somebody that syscall.c really is the user space part of this, right? No way. Definitely the kernel. Usys.s, that's the one. Yeah, I guess I had never actually understood how system calls work here. And this is how they work. So we generate some assembly. Or, well, we just use a define, use a macro to create some pretty basic assembly. But that's what I expected. So now this thing, yeah, this part is user space, but it's a client of these defines, but the macro makes it impossible to see that in the grep output. That's why. That's interesting. I don't actually know how the arguments really work here, because all this is doing is moving a single syscall number into the register and then triggering the syscall interrupt. So it's relying on the compiler. It's totally like not type safe is not the word I'm looking for, but there's no validation of like arguments here. You could even pass in like unlimited arguments. No, because the header file, yeah, the header file determines what arguments are there. But the interesting thing is that the implementation of the actual functions or like symbols or code doesn't actually receive the arguments in any way. All it does is create a symbol with the same name. But since it's assembly, none of like the notion of return value or even arguments doesn't exist. So all you can do is create a symbol, which can be called, okay, got it. That's all to say that I can't move all these numbers into the C file, which I was considering doing. That's all to say I need to do this. And then we do our same little dance. Although, wait a sec, so it's used by syscall.c, which hopefully already includes syscall.h. I'm just gonna add the little space there. Clean up. And sys file. How does this thing not include? Oh, okay, yeah. Because actually no, that's wrong. It's not. Yeah, this is correct. And then sys proc. Right, and I think that's actually. What else? Sys file, fetch int. Yep, sys file, sys call. Interesting. So who is calling syscall? Trap.c. Nice. That makes sense. Traps.c is the main receiver, or like a dispatch. Yeah. So that's like that. Cool. Kernel. Oof. Syscall.h. Is that this? What's syntax error or expected? Oop. 20-second break. Okay. What now? What is line 30? Something is wrong. Why? types. We're missing the include for the uint thing. Wow. Oh, damn. So now we need this. Oof, that's messy. So this file is included from assembly, which I think, mmu.h is a similar thing. And the solution there is to use these if-defs, which I do not love. But I don't want to have like a lot of them, but whatever. Maybe I will tolerate it. Okay. Interesting. The auto formatting automatically tabs in the include, but then not this stuff. Good. Okay, so now we're back in business. Ooh. Okay. I think that's good. Code review, syscall dot h. Then just these three things. Nice. Okay. What's next? Ooh, I kind of want, no. What did I just create? It was like, I'm just going to copy this one again. Okay. Duplicate. But I don't know. I didn't decide yet. We only have a couple left yet. FS seems big and annoying. Spin lock. Let's do spin lock. I actually kind of wanted to write my own. Oh, spin lock.h already exists. Yeah. That is interesting. They keep so much debugging info in the spin lock. They keep a call stack in the spin lock. That's cool. Okay. Okay. So that's pretty easy, I think. Spin lock. Oh, interesting. Sleep. Yeah. Quick double check. Are these context is no longer needed? inode is definitely needed. Proc is needed. Okay. And yeah, this is going to be a extremely widely used API. So we're going to need this thing pretty much everywhere. Just going to calloc log pipe proc sleep lock. Sleep lock uses a spin lock. Interesting. Spin lock itself. Sysproc trap.c. Okay, nice. Now we just go through all of these and add a, but it already has it. Yeah, do all these already have it? Yes, 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 yes. Yep, yep. Yeah, in order to even use a spin lock, you already need to have the header. So I think this one is really easy. It's just this little cleanup, actually. Although this one was missing it, so that's a little bit of a cleanup. And I think that's it, actually. Oh. What happened? Did I delete something by accident? No. Oh, vm.c actually needs it. Spin lock for these interesting interrupt instructions, which seems wrong, but it's not a fix I want to make right now anyway. This is that cleanup commit. Okay. And create, or no, move spin lock prototypes to spinlock.h. Good. Okay. No. I mean, I'm kind of curious. I just like, so I'm like, spin locks are a super basic thing to implement like in an OS. They're really simple. And they're nice because they're low overhead, or not they're low overhead, they're low dependency is what I meant to say. And they're pretty simple mechanisms. And my understanding, before I try to read the code, my understanding of spin locks is that you just have like an int or something, or even maybe just like one byte, like a bool. And then you use atomic instructions to atomically set the state. And if someone wants the lock, they try to set it to 1 unless it's 0, and this attempt to set it needs to be atomic. Let's see if I know what I'm talking about. Init lock, acquire pointer. Now this is something I don't know too much about, but apparently you need to disable interrupts while you're locking a spin lock. So we're asserting that it cannot be locked, and then we're trying to make it 1. And I think it returns. I don't actually know what is that? Oh, interesting. That is pretty low level that we need to implement our own like atomic swap using assembly. I would have thought that we could use like GCC atomics, but maybe we actually can, but this is quite low level to be specifying the actual. Wow. The plus, and it's a read modifier write operand. Did not know that. That's cool. Okay. Yeah, I don't know the syntax super well for this inline assembly stuff. Basic premise though, take the address. That goes into the first one, I think. Take the second one. I don't know what this one. Oh, that corresponds to this. I suppose. Yeah, I'm not sure. It's like an output thing, goes into result, and we return that. Okay. Yeah, I would need to like look some of this up. This is interesting. See, apparently you need a barrier or something. like that. Give me a sec, yeah. So we actually are using legacy. Oh wow. Full memory barrier. So that's a full memory barrier. Okay. Yeah, interesting. The critical section's memory references happen after the lock is acquired. The critical section being the code after this function runs. Basically, we don't want things to like drift up past this point. Yeah. Okay. I think I'm so not an expert in this, but I think this is a bit excessive or something. Like, you know, I shouldn't comment. I don't know, but there's like acquire and release semantics, and like this barrier is like a super strong barrier that prevents anything from crossing it. But there are situations where you don't need quite such a strong barrier. Oh, oops. My desk just moved. Okay. So apparently that's necessary, but yeah, interesting. I wonder what would happen if you just didn't have that. Would you have bugs? Maybe. Okay. Then just whatever, this stuff. Okay, cool. Where were we? This makes, okay, so this works. So now we get to move on. Okay, now it's all just these big ones that I've been avoiding this whole time. Let's do vm.c. Let's do vm.c. Is there already vm.h? No. Okay. Duplicate. We are the first creators of vm.h. Okay, we're... How did this work before? Defs.h. Does types.h have all this? Oh, interesting. Who uses this though? Apparently a lot of people do. But this type def like should not be here. It should be in vm.h, I feel like. But it's not a change I will necessarily make right now. But if it's in types.h, why? What's wrong with this? I feel like it's wrong. Incomplete type. It's not allowed. Okay, now it decided to stop. And now we walk through this long list of functions, although I kind of suspect that a lot of them are private. Nope, I'm wrong. Okay. Well, at least for that one. vm.h kv malloc. Also main setup kvm exec and proc. This thing. This is actually private, so this does not okay, technically I should do this should have done this first then. So this one, so now I just want to take a note somewhere. Here, UVA2KA should be static, I think, yeah. Overall, it's just exec, proc, and VM. Those are the main clients. Free VM. Init UVM. Load UVM. Okay. Whoa. What was that about? TSS? Did I see? Okay. Proc, switch, UVM, exec, proc. Or switch UVM, switch KVM. Interesting. But it's all the same. Main, proc, VM, copy out. Okay, nice. So it's really just this one that could be static, I guess. Yeah. Let's see. Nice. And we are still, ooh. Wow, what? vm.h. Oh, okay, so there were all these forward declarations, which inode. Okay, yep. There are these things. Okay. So take this, move it here, add this thing. Places, cool. And then as a cleanup, UVA2KA. I think this could be static, right? Yeah, totally. Okay. Okay. And now it's just these two. Okay. 20-second break. Okay, we can delete that file. Right? Why is that? Okay. Moving on. Proc.c. Don't save. Okay. Is there proc.h? There is already. With a lot of these very important structures, CPU. Okay. So, do I just add this at the bottom? And then probably take away some stuff. Yep, like this. Anything else? That might have been the last spinlock reference. Yep. What context? That's never been. Okay. Okay, nice. CPU ID. Proc. Trap. VM. Proc.h. Okay. Exit. Init. This is user space. We don't care. We actually do care about this. No, this is user space also. Who is this? It? That's no trap. Tests. What is zombie.c? What? Oh, huh, okay. Trap already had it. Yeah. Yeah, it was trap. And sysproc, right? Oh, but it already had it too. Okay. Why did it already have it? It's like these other ones. Yeah, okay. Fork. It's kind of annoying that these functions are the same name as all the user space ones, and I can't even filter out for user space files because everything's in one folder. Tests. But I think, okay. Yeah, grow proc. I think there's a fairly limited number of like files that use all this stuff. Kill proc syscall. Yeah. My CPU, that's used everywhere. Oops. Ugh. Proc.h. So, but everything kind of already has includes, so that's proc.c. Like everything already has includes, because as soon as you call this function, you need the struct definition, which everyone was already getting. So there's no one that was calling my CPU and didn't already include proc.h. pinit, just main, proc dump, console.c, scheduler, shed, proc.c, yeah, set proc, sleep, nope, log.c, that would be, yeah, that's someone that actually could use it. Pipe already has it. Sleep log. Yep. Sys. Sleep. Okay. Getting there. And wait. Test. Wait is a syscall, right? Okay, yep. But it was okay, yeah. And the implementation of syswait just returns wait. Yep. And that's the only use, actually. Okay. Huh, interesting one. Wake up. IDE. Log. What is it doing? Waking up a thread or waking up a task or not sure. Sleep walk, trap. Okay. Finally, yield. Trap. Yep. Okay, cool. I think we are done with that. Oh. Proc.h. There's that weird dependency on the spin lock. Okay. This. And that was the only one. Very simple. Create proc.h, right? Yeah. And we are almost there at the end. Except for this annoying thing. Wow. Which just like doesn't belong here. Okay. fs.h. Is there fs.h? There probably is. Yep. This is like pretty involved or something, or okay, it's all the file system stuff. Yeah, I wonder. So all this stuff goes away. And we just have like totally hollowed out this whole thing. Log.c already included it. Probably almost every client will have already included it because there are so many structs that are needed. By definition, pretty much. This doesn't have it though. But otherwise, by definition, if you are calling any of these functions, you need these types. So anything here is going to already have fs. Literally, so name comp. This file definitely has it. So I think pretty much know what's going on. Declaration incompatible. No idea what it's talking about. File.c, probably. Let's see if it. Oh. Oof. Make a fast so annoying. Wow. Trying to build this make a fast thing. Will not be visible. Okay, so this is a problem. Makefs includes this file in a user space program on my host, and it won't have any of these functions linked into it. So what do? I can make another header file. It's so annoying. Oh. Can I make it? Can I use an if def? Ugh. If it's like the if def is like if building for the kernel. Include this. That's yucky. I do not want to do that. But I think that's the issue, yeah. Also, so what? ialloc. Holy crap, wow. So who's using XV? Is that even used? Or no, I'm so any use of stat translates to this, right? But still, someone needs to be around to do something with this xv6 stat, and I don't see any reference to it. And it also really Also, what is it? Oh, this is yeah. Somehow they have their own static assert. Okay. Okay, so never mind. It actually... Seriously? Was it really like linking in kernel code? And just running it outside? Alloc? But then what about I append? Is that implemented here? Okay, it is. Like, a lot of this is... Even this thing is. Okay. The next question is that copy and pasted from the kernel? Okay, definitely not. But now we have issues. So basically this is all broken. Like, we need to make sure that these types, these functions, yeah, I think a separate header file is the solution here. So I can leave all this here. And that, yeah, this is probably not worth spending that much time on. Duplicate fs functions. It should kind of be the other way around. I feel like there should be like a header file for like the types. Yeah. Back to the Git. Let's see what. Okay, so that's maybe a bit premature. First, I suppose the first thing I want to actually do is types. And then I delete this thing. And then I delete all of this. Approximately is how this is going to work. So now then, so this is the diff I want, and then this is the thing. So take this all, split this out all into our new fs types. Yeah, I do kind of want to move towards a different naming scheme, like camel case, but for the moment, yeah, I won't. Okay, this is just code movement, so I think this should be totally clean. Okay. Okay. And then we can Now we're back here. Now we can remove this. Yeah, I guess the last commit was kind of interesting because because that fs file is just like a little bit weird and empty. But now we just add this back. And what's up with this also? Yeah, whatever. So now the main point of that was now makeFS depends only on fs types. And now we don't have quite so many problems. And file included from buff.h. Declared. Yes. Something is okay. So now there's this issue. Yeah. So technically, also this is buff.bio. So now for certain things, but for anything, this doesn't really make sense. File included from buff.h. So this thing, so do I need that? I do. B size. Okay. Wow. From bio.c. 24. So this thing needs buff, and this thing needs fs. Okay, I don't know. Maybe something like this. I think, what? Oh, I am dumb. Oh, wait. Wait, no, wait a sec. inode is clearly here, right? Is it not? Where is inode then? Ooh, struct inode. File.h. Oh, that explains it. Do I even need fs? What? Okay, so definitely need file.h then, because apparently that's what has the inode. And we don't need fs types? That's so confusing. Well, really all we need is struct inode, actually. Now I expect there will be some errors, yeah. I think I'm going to relax the header like strictness. I think technically I should be going through like every place that includes fs.h and maybe also inserting an include on fs types. It depends on details I don't feel like looking up right now or caring about. I'm just gonna get this to work with the struct stat thing. Okay, build. Wow. Okay, but this is good. So now exec.c somehow needed. And vm.c. Cool. Q. Was that necessary though? Buffed and the buff.h thing? Oops. Whoa. Oh. No, I don't think that was weird. Yeah. This was necessary. Whatever. Okay. Nice little cleanup. Hello? Okay. Yeah, it doesn't make sense for make fs.c to include the kernel functions. Right. Okay. And yeah, that's kind of almost it. Now we just need to figure out what to do with this thing. Which we will rename to util. Right? What else would... And then now place in files defs.h util.h. Didn't want to do that. How do I... Yeah. Oh yeah. But that's not totally right, because it's like only people that actually need it, which is like 3 places that already have it. How does this call of all? Oh, it does. It says file, of course, and VM, and everyone else. I should probably keep a note. So it's proc VC. Oops. Okay, anyone else does not, defs.h is no longer a thing. Or util. So this might kind of suck, but okay. But I just gotta, I guess I go through here and just like delete that line everywhere. Feels kind of good, I guess. I don't know what's going on. Okay. There's probably some way to do this faster. Time to ask ChatGPT. How do I remove and include line from many files in my C code base with a command line? Find, execute said I. To delete. That is cool. I did not know about that. So now, yeah, I'm going to try that. So I need to like ag for util.h, right? Ag is almost true. File name only. Right. Perfect. V. Something like proc. Yeah, proc and sysproc. But oh, that's annoying. I still wanted sysproc in there. Okay. Proc or syscall or sysfile or VM. Now this big list of people that use util.h. A couple of them actually need it. Otherwise, most don't. And here's where I always forget the xargs thing. Something like this. Sed.i. I don't know. What's that weird thing at the end? Is that even needed? The backslash semicolon. Okay. Include util As just a quick thing, I'm going to stage this before I do other changes. Right, okay. Run. Did I do that wrong? Using XRs. Is my sed the wrong sed? So like G sed or something? Yeah, maybe that was it. Look at that. That's beautiful. Wow. Okay. So this thing gets moved. A handful of things. Sysproc. Wasn't that one of those? No. A handful of things actually needed util. They get it. Everything else just gets the defs thing removed. And I hope that builds. Make kernel. Defs. What? Ooh, overwrite. Don't save. Save. Okay, something's messed up. No rule. Make target debt needed by buyout age. What does that even mean? What? kernel. Yeah, something got weirdly cached in the build or whatever. Okay, great. That's awesome. Okay. And there it is. That's what we were trying to do. Devs.h. It's just not there. Cool. Now we have this nice little util.h. And we have like all these header files now. Very granular one for like for every single C and header thing. Now we have like 4 files for the .o and the .d. Yuck. Okay. Yeah, very yucky. Okay. So now what? Now, I guess it's time to go through the history and see how to make it better, or maybe rewrite some of these commit messages. Create, refactor. I think it's a bit noisy just to heap. 20-second break. But maybe I'm not going to try too hard. I think I am kind of tired, and I think this is all pretty reasonable stuff. Yeah, no, I think I'm gonna just call it here. Okay. So that was some good work, good progress. And now we can just merge this in with a big capital M. Look at that. Yeah, look at that awesome merge commit. Check. We'll take a look in fork. Perfect. Very nice. Push that off. Nice. All right, cool. Well, that did it. We finished our big migration effort to get rid of defs.h, and actually it had header files everywhere, which was just kind of some janitorial like work, very mechanical. But the point was to move one step towards actually working on like C code and stuff, which to some degree I did, although it was just very mechanical and not very interesting stuff. I think in the future, I want to see how I can do a bit more substantial work on this somehow. But I'm going to end the video here. Thanks for watching. I'll catch you in the next one.